Good morning everyone, my name is Stuart Smith, as most of you know, and today we're going to be talking about ball bearing steel. Now I get a lot of guys asking me when I tell them that the knife has been made from ball bearing steel, did you melt it down? Did you put a whole bunch of them together? It's because when they think of ball bearings, they generally think of this as ball bearings, which makes sense because it's small enough. Maybe you could forge it down, but there's too many little different types of metal in here, a couple of imperfections. Forging this down might work, maybe you've had it to work before, but personally not myself, and melting it down, I don't have the facilities to melt this kind of steel. So I then correct them and say, no, this is not the kind of ball bearings we use. This is the kind of ball bearing we use. Now this here weighs about 20 kilograms and is made up of, let's try again, see if I can do it without. Okay, it's made up of an inner racing, an outer racing, a bronze bracket, and a dozen or so roller bearings in this case. Now the difference between a roller bearing and a ball bearing is a roller bearing, in my nice new Valhalla shirt. Okay, a roller bearing is cylindrical, and a ball bearing is a ball. Roller bearing, ball bearing. Both of them work, but I find that the roller bearing is naturally easier to work because of its longer shape. Okay. Now, most ball bearing steel is made of something called 52-100. You do get the cheaper ball bearing casings that are made from case hardened steel. Case hardened steel is basically a lower grade steel that the outside only has been hardened. This is a much cheaper way to make it, and as a result it has poorer quality and is no good for forging knives. So with every bearing casing that we use and every bearing that we pull from that casing, we need to forge a bit out, quench it in cold water after heating it, and whack it with a hammer. If it shatters, it's a good indication that it's a high carbon steel. If you hit it and it bends, it means it's low carbon, it was case hardened, and is no good for knives. Now I've done that before with an entire casing. Before I tested it, I forged them all out, and when it came time to quenching, after grinding 6 knives, I couldn't get them hard. And then when I stuck one in a vise and I hit it with a hammer, nothing happened. So remember, always test first. I have high confidence in the ones that I've got here. These were precision made for a company for some large generators, and they were slightly under spec. So these are brand new, unused bearing casings for the highest quality standards. Now, 52-100, which is usually, not all the time, which is usually what bearing steel is made of, is a 1% high carbon steel with around about 1% chrome in it, which gives it that extra hardness and wear resistance. Now, bearing steel when hardened is extremely hard and extremely brittle, but with the correct care and the correct heat treating, you can make a knife of superior performance, much like Ed Fowler does. I mean, he's the only guy I know who can perform 180 degree bends on a 52-100 knife without it work hardening or breaking. You don't believe me? Look it up and check for yourself. Now, I've seen the same thing done with 5160, which is spring steel, which is incredibly impressive in itself, but the spring steel doesn't have as high carbon content as the 52-100. So what we do with this incredibly large casing is we take an angle grinder, we cut the ends out to separate it, and then we remove the top of the bearing housing, which is the bronze, and then we can pull the ball bearings individually out. And from there we just take a handle, weld a rod on the end, and we put it in the fire, and we either hammer it or press it out. One like this will make 2 Puukko knives. It's actually quite heavy, so if you weigh your knife and you see how much material is in it, these are extremely heavy, so there's a lot of material in here. And I've got, like I said, a dozen and a half or so that I get out of the bearing. So I'm just going to turn the camera around now so that you can see the one that I've just cut up, and you can see all the components that we can use. So you can see there, I've got all my rollers, we've got the housing, the outer casing. Now the problem with the outer casing, you can see here, let's see which side is better. There you go, that's better. You can see it's got this little channel in here. Now this is unfortunate because if you forge it incorrectly, that will fold over and create a stress line, or not a stress line, but like almost like a crack or a fold inside the steel. So what I do is when I take out the piece, when I cut the piece off that I want, I will then take an angle grinder and I will just cut from there like that. Cut that corner off and remove this lip. Now this is the last ditch portion of the very large chicken, that is roast chicken, that is the bearing casing. So this is the white meat. We want to go for the dark meat. The bearings are the dark meat, and this is the dark meat. Yeah, this is the case. This is the inner casing. Now the inner casing is solid. There are no folds in it. It's ideally suited for forging out into blades. Now the nice thing about the inner casing is we can make larger knives with it as well. Now remember, when you're working with high carbon steels and you're making large knives, you have to temper it much higher in order to increase the toughness of the steel, so that the blade isn't too brittle for such a large knife. Because you don't want to have a camping knife and take it into the bush and it snaps on you because it's too hard. Alright, so with that, I will post some pictures of these bearings here being worked. I'm going to cut one or two pieces off the casing here, the inner casing, and yeah, all the bronze here for the brackets, I don't know, I'll cut up, maybe melt down, depends on what kind of bronze it is. I have to check with some friends. So yes, no part of the entire ball bearing, well in this case roller bearing unit, goes to waste. So thank you very much for watching, and remember to subscribe to my YouTube channel. Also give my Facebook fan page a like, and you can follow my work there to see what I'm doing. Thank you very much.